And I will now go into the fun topic of how do we extract data from the brain? What information should we extract? How do we know that this information is useful? And how do we make sure on the other side that this is something the industry needs? And how do we know that also people will want to invest in it and that overall this is going to be good for business? This has been a question that I really enjoyed thinking about in the past years. And this is one of my favorite experiments. It's actually an experiment done in the lab of my professors, which received not one, but two Nobel Prizes for this one. And I just wanted to show you today because I think it's really, really beautiful. I often get to see data that is not convincing, and that upsets me as a scientist. But once in a while, we get to see things that are so clear coming from neuroscience that it becomes really obvious how we can emulate that, and it makes everything easier because then there are so many other questions that we can come up with, which, by the way, I invite. Sorry, this will take a few seconds until it starts to make sense. So just to briefly explain, this mouse has an implant in its brain, and basically it's recording from a single neuron called a grid cell. And every time this grid cell is active, there is a white dot in the location that the mouse was when the neuron was active. So for now, it looks like the grid cell is active in random locations of the box. And this actually took people a while to understand because it looks like this is random. But you see now, if you give the mouse a bit more time, now you see where the term grid cell comes from. This is starting to look a lot like a grid. And this is why I mentioned this example. It's also very related to my research. But actually, if you take a line through the clusters, you will see that the distance between the centers of the clusters is always equal. And this was shown to be one of the few structures in our brain that is perfectly mathematically, well, perfect if we're really going to look at the grids. And this has been shown again and again in thousands of experiments in different kinds of species, bats, humans, primates, mice. And a lot of my work at Robotics has also been about emulating that. Can we use that to understand autonomy?